Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello all, and welcome to today's session on GeoAI Education. My name is Andrea Manara from the ITU, the International Telecommunication Union, and it is an honor for me to introduce a new episode in the GeoAI Discovery Series. This series is curated by three outstanding geospatial professionals, Nadine Alamé, Maria Brovelli, and Barbara Ryan. We launched this series beginning of 2022, and we discussed the GeoAI applications and policies, ethics, and the future of the GeoAI for Good. Thematic sessions included climate actions, spatial digital twins, energy, ecology, agriculture, water and food systems, and also health. If you missed some episodes, don't worry. You can watch the recordings of those events on YouTube or on the neural network to which you are connected right now. Without further ado, let me now introduce Dr. Sonyan Lee. He has been a faculty member in the Department of Civil Engineering at Toronto Metropolitan University since 2001, and is now a professor of geomatics engineering. Prior to joining Toronto Metropolitan University, Dr. Lee taught in Wuhan Technical University of Surveying and Mapping and Ningxia Institute of Technology in China for 14 years and spent 1 year at Lakehead University as a visiting scholar. He has served as adjunct professor or member of graduate programs of a number of universities in Canada, China, and Japan. He will moderate this session and introduce you to the outstanding speakers of today's session. Sonyan, the floor is yours.
Thank you very much, Andrea. Good morning, good afternoon, good evening. Thank you for joining our GeoAI Education webinar. This webinar is organized by the Academic Network of the United Nations Global Geospatial Information Management, often named UN-GGIM. As Andrea introduced, my name is Sonyan Lee from Toronto Metropolitan University in Canada. I'm a professor in geomatics and the deputy chair of the UN-GGIM Academic Network. I'm very pleased to have the three distinguished guests with me here in the session, which I will be introduced later on, who will be presenting and also act as the panelists in the discussion session. Professor Maria Brovelli from Milan Polytechnic University, who is also the chair of the UN-GGIM Academic Network, will co-moderate this webinar with me. Thank you very much, Maria. As we all know that GeoAI is an emerging field that combines geospatial information science, artificial intelligence, data mining, and high-performance computing to extract knowledge from geospatial big data. Over the past many years, we have seen big research progress and developments made in GeoAI. However, not enough attention has been paid to its education and training. As such, this webinar features 3 expert presentations and a panel discussion to examine the challenges and opportunities in GeoAI education and training. We also hope that this webinar can help address the needs and concerns of educators, employers, and other stakeholders in the GeoAI community. With that, without further ado, I would like to introduce our first presenter, Dr. Ali Mansouri. Dr. Mansouri is an associate professor in the Department of Physical Geography and Ecosystem Science at Lund University in Sweden. He is currently the director of Lund University GIS Center. He has a background in geomatics engineering with specialization in geospatial information systems and spatial data infrastructures. He has long-standing research in spatial temporal modeling and analysis using AI techniques. Dr. Mansouri will talk about challenges and experiences in GeoAI education. With that, the floor is yours, Ali.
Yeah, thank you very much, Song-Yang, for the introduction. Good morning, good afternoon, and good evening, everybody. First of all, let me share my screen. Good, I hope you can see my presentation. So, my presentation, as Song-Yang introduced, is about GeoEducation, challenges and experiences. I am Ali Mansourian from Lund University GIS Center in Sweden. Actually, before talking about GeoEducation challenges and experiences, I want to have a very, very short introduction about Lund University GIS Center and where I'm coming from. So in the southern part of Sweden, there is a small city, but beautiful, which is called Lund. And this city is home of Lund University. Lund University has been ranked among top 100 universities by QS during the last 50, 60 years. And this university has a department of physical geography and ecosystem science that I'm coming from. And this department has been ranked among top 25 in geography, also by QS. GIS Center is part of the Department of Physical Geography and Ecosystem Science. And it's one of the well-known GIS centers in Northern Europe, and different research groups are working on different topics related to GIS, remote sensing, and SDI in this center. One of the research directions at the GIS Center is related to geospatial artificial intelligence that I'm leading. And as a result of that, we have been involved or leading different projects where GeoAI has been part of it. So this presentation has been prepared based on these experiences. But talking about GeoAI, GeoAI is a type of AI, we can say. So I have some definitions about AI. Actually, when you search internet, you get different definitions about AI, which might be a challenge by itself, where there is not any standard definition for it. But I found two interesting definitions here. One by Wikipedia, which is emphasizing on intelligence, which is perceived by machine from data or information from different resources. And this is opposed to intelligence displayed by humans and or animals. And another definition I found is by OECD that emphasizes on AI as a system that can make predictions, recommendations, and decisions that can influence real or virtual environments. I think that if we merge these two definitions, then we will have a good definition for AI. It could be a type of intelligence which is perceived from information surrounding us, and this information can be used for prediction, recommendation, and decision-making. AI, as you may know, is not a new topic. It was introduced as a research topic in these days, and deep learning is a part of it, was introduced actually in those days. It was a single perceptron model that was introduced. Actually, AI was developing fast in 1950s until around 1975, but then it has a winter era because it collapses to in the perception of the value of AI by governments and venture capitals. So due to lack of funds, actually, it didn't develop well, but then it had a new hype, and popular expert systems such as XCON and LIPS machines were introduced in those days. And also expert systems became very popular that simulated decision-making of human experts to solve specific problems. And it was used for example, diagnosing infectious diseases. But then we witnessed a winter in AI, and finally, it has an explosive growth. And as you know, this explosive growth is because there is a large amount of data on cloud environments that we know them as big data, which can be used for training machines to create intelligence. And AI is part of fourth industrial revolution. So keep this in mind. We have to consider about integration of AI with geospatial data and geospatial applications, which is known as GeoAI. So GeoAI is about integration of geospatial data and AI techniques. And we can say that there are different applications of AI in GI science. In order to summarize these applications, I have just picked three main areas in geomatics, which is GIS, remote sensing, and spatial data infrastructures. And in SDI, I focus on geoportals. But as you know, when it comes, for example, to GIS, you can use optimization techniques from AI to solve complex problems related to a spatial multi-criteria decision analysis. For example, multi-objective optimization techniques can be replaced to traditional multi-attribute decision-making techniques to solve complex problems. Or you can use machine learning to solve different geostatistic problems, to do a spatial temporal analysis, or to use it to produce predictive models. And in geosimulation techniques, such as agent-based models, can be used for dynamic processes in space and time. And when it comes to remote sensing, you can use machine learning for classification of satellite images, object detection, or change detection. And when it comes to geoportals in spatial data infrastructures, you can use a combination of optimization techniques, machine learning, and, for example, agent-based models to develop solutions for automatic composition of geospatial web services. So there are many, many applications of AI in GI science that makes it important for us to consider it as a topic in GI education. But if you want to have a GeoAI education, let's say to develop a course, for example, related to GeoAI for students, then we face different challenges. And these challenges is because of the interdisciplinary nature of GeoAI, and it's also because the complex interaction between geospatial concepts and AI algorithms. I've tried to demonstrate these challenges in this presentation. So I actually, based on the experiences that I have, I could identify 7 important challenges that I would like to present here and then discuss it in the panel session. The first challenge, I think, is related to the variety of techniques and algorithms. As you know, there is a long list of AI techniques and algorithms which are relevant to GeoAI. For example, if you pick the optimization techniques, which are part of AI, then you have meta-heuristic and different other algorithms. If we take the meta-heuristic branches, then you have a single solution-based search or population-based search. So if we pick only population-based search, then you have evolutionary algorithms or swarm intelligence. And in each category, you have a long list of algorithms available. Related to machine learning, actually, I asked ChatGPT to give me a list of machine learning algorithms. Then you get a very long list of machine learning algorithms, from random forest to support vector machine to artificial neural networks to convolutional neural networks. And you have a very long list here also. So the question is, if we want to develop a course related to GeoAI, which techniques and algorithms should be included in curricula? And what should we focus? Should we focus on optimization? Should we focus on prediction? Should we focus on geosimulation? And as I said, which algorithm in each category should be used? The second challenge is related to the technical complexity of GeoAI. You know that in order to teach AI to students need to have a background in geospatial analysis. They should understand programming. They should understand a bit of data science. But we have students with different backgrounds. Some of them, if you consider, for example, students at master level, which is more suitable for training GeoAI to them. Some of them has a background in physical geography, some of them in human geography, some of them are in geoinformatics and informatics, which are more technical, and some come from other engineering domains. So GeoAI includes working with large geospatial data, complex algorithms, and specialized tools for data processing, machine learning, and spatial analysis. And the question is, do these students that sit at the classroom have required background, as I said, related to programming and data science to learn GeoAI? And if they don't have this background, how can they be prepared in order to be able to study a GeoAI course? So this is the second challenge, which is related to technical complexity that need to be considered. The third challenge, I think, is related to GeoAI dedicated algorithms. So if you want to use, for example, machine learning in GeoAI domain, in a GIS application, let's say, you can pick, for example, a raster map. You can extract some data from that map, and then you feed it to a machine learning to train the machine. So you can treat spatial data similar to non-spatial data or attribute data to train a machine learning model. But if you, I can say that, I want to say that you can extract the data from map and then treat these data like you treat them in normal data science. But we know that in a spatial data or in a GI domain, we have a concept which is called a spatial effect, an autocorrelation, and a spatial lag. It means that when you are analyzing the data, you have to consider the effect of neighborhood data or the closest data to your existing data. So a spatial autocorrelation is something specific for geospatial data that needs to be considered when you want to use GeoAI. And new algorithms, which are known as geospatial machine learning, has been developed in this line. Up to my knowledge, geographic weighted random forest or geographic weighted artificial neural network and graph convolutional neural network are some examples of these dedicated algorithms. But the challenge is, again, what do we teach? We need to teach the basics of AI to the students, indeed, and also we need then to teach them GeoAI, but do we have enough time? And what is the best balance between traditional and GeoAI techniques? This is something that we need to consider when we are designing curricula for a GeoAI course. The fourth challenge is related to implementing active learning teaching. You know that active learning teaching that I use is abbreviation ALT, refers to teaching strategies that engage students as active participants in their learning. And if you consider Bloom's taxonomy, it has been shown that when you use ALT techniques, students will have a higher level of learning. And there are a broad range of techniques that can be used in a classroom, it can be used in laboratories, and it can be used for individual activities to keep students active in their education. But the question is that which technique can be used for ALT in GeoAI education, and how the ALT techniques can be implemented for each piece of GeoAI education. This is something that we should consider and we should work on that. In order to give you an insight, actually related to SDI, recently we worked on a project which was called Spider. It was about open spatial data infrastructure education, which was a collaboration between 5 European universities and the support of big GI associations around the world. And in this project, actually, we tried to develop or propose ALT solutions for each piece of SDI education. So we identified, as part of the project, we identified different topics. And for each topic, we actually introduced different techniques, ALT techniques, that can be used for teaching that topic. And we presented it as a toolkit, which is also available in a Spider website. I believe that we need to develop a similar topic for GeoAI education to have some roadmaps about how active teaching and learning can be implemented for GeoAI education. The fifth challenge, I think, is related to legal and ethical aspects of GeoAI. You know that there are different initiatives are ongoing in parallel to the technical activities to clarify legal and ethical aspects of AI. An example is, for example, European Commission initiatives to develop some sort of laws and regulations for the use of AI. And different topics are discussed when you consider legal and ethical aspects of of AI. Discussions are about the risks, are about trust versus safeguarding, how we can motivate companies to use AI without being afraid of the risks. Discussion about privacy, about the copyright. But which of them is relevant to GeoAI? I think that is a question. And then the second question, if you are designing a course, is that how deep should these non-technical issues be covered in GeoAI education? And also another challenge that I have identified is that when you are talking about, for example, privacy and copyright of GeoAI, I have observed that people discuss about data privacy issues. But when we want to include this issue in education, what is the boundary between legal aspects of data or publishing data and legal aspects of GeoAI? So which topics should be taught in geodata related courses and which topics should be taught in GeoAI related courses? So we need to find this boundary in order to make sure that we don't repeat the same things for students in the GeoAI courses. The sixth challenge is that AI is evolving and developing super fast. You've read in the news recently that different warnings are being given about the risks of AI because it's developing very fast. But if we look at it from education perspective, we can say that new algorithms are developing, new techniques are developing, and it influences actually updating the course materials. So if we develop GeoAI courses, what should be the tempo for updating the course material? And to which level this course material should be updated? And we left the rest for the students to study or to learn in higher levels, for example, in PhD or postdoc. So this is also something that needs to be considered. As I see it, if GeoAI courses are being developed, the curricula should be dynamic for a few years until we can find a balance that super fast updates are not needed in order to keep the curricula up to date. But this is also another challenge that we need to consider. And the seventh challenge, I think, is related to evaluation of students. So the question is what to evaluate. Should we evaluate the theoretical knowledge of students or practical skills, or both? And in order to evaluate this, how the evaluation should take place? Is a theoretical exam enough? Or is a theoretical exam needed at all? Because students can use existing libraries. So do they need to know about theories very well? Is a combination of theories and practical exam needed? Is a combination of theoretical exam and a final project is a good solution? So how to evaluate students is also a question. AI has theoretical aspects, which are important in a way, but it has also a high weight on practical skills. So how they need to be evaluated and how the exams should be designed. That's a question to be discussed, actually. As a matter of experience, this is my last slide here, actually here. Recently, we have developed a GeoAI course for GIS and RS master program at Lund University. And considering these challenges, actually, we designed the course, including theoretical and lab works, to include a bit of active learning teaching in the course. And then we decided to include in optimization, for example, a single objective optimization with focus on genetic algorithm, and a multi-objective optimization focusing on NSGA2. And then we focus on machine learning, and for machine learning part, we just picked a few techniques such as regression, decision tree, support vector machine, artificial neural network, and deep learning with focus on CNN and ensemble learning. In order to evaluate theoretical knowledge of students, we designed some quizzes at the end of each module, as you can see here. And then we have one module that focuses on geospatial weighted machine learning. We introduce some basic concepts to the students, but we cannot go into details. And also only one lecture about ethics in SDI. We have considered a seminar that students have some self-learning and some self-studying, and a big project that also determines the final grade of the students. So this actually combination is for a 7.5 credit course equal to 5 weeks work. I don't say this is perfect, but based on different discussion meetings, we found this syllabus as something that can actually cover different aspects of GeoAI education, but it will still be developing. Thank you very much for your attention. And this is the end of my presentation.
Thank you very much, Ali, for this insightful presentation. I'm sure we will have a lot to discuss, and we probably also have some questions which we can hold at the very end. Thank you. So our next presenter is Dr. Lukendra Chauhan. Lukendra is the founder of King Labs Incorporation, and he is also the co-chair with the OGC GeoAI and Metaverse domain working groups. Dr. Chauhan's interests are in GeoAI for sustainability in agriculture and SDG measurements. His presentation title today is GeoAI Education, How Differences and Similarities Between GeoAI and AI Impact Training Needs. The floor is yours, Lukendra.
Thank you, Songyan. Just as I'll share my slides first and then. Right. Can you see my slides?
Yes, we can.
Hi. Thank you, everyone. Thank you, Songyan and Maria, for inviting me here. So I'm, as Songyan said, I'm Lukendra Chauhan. I'm an entrepreneur based in Minneapolis, and I focus on bringing GeoAI algorithms from academia or research to practice in the industry. So I try to connect between the two domains. My presentation is I kind of just realized that my presentation is not going to be very different from what we saw from Ali, and actually mine is going to be much more shallow. Ali's was definitely had more depth. But anyway, I'll just continue. Okay. Yeah. So we have heard, I think in geospatial industry, everybody talks about everything happens somewhere and almost all data is geospatial. So that's why geospatial is important. And yeah, we can go into that, but yeah, you collect data anywhere, almost always you can have a location tag attached to it and you can call it geospatial data. So that's why geospatial is important, and the industry, the world is realizing it slowly. So that's a good thing for us. Now, my take on this that in industry, like, so what we have is like there are three different kind of groups to whom we have to cater, especially in terms of products, etc. And first one is experts, where often they make the products usually, and then which is like researchers, etc. And then you have analysts who are trying to find the answers to the specific questions, and then you have individuals who are using all the apps which use geospatial technologies without even sometimes without even actually knowing that there's geospatial technologies being used behind them. And I'll come back to this thing later, because in one of the later slides I would need this, but no. Ali also explained what is AI, and I tried to explain it in somewhat shallow terms. So my take is that we have had software or expert systems where when you knew okay what to do with data and you had all your rules, you could code them, and yeah, you use data and those rules in a codified form and get your answers. Now, the difference AI or what we can call as learning systems have is that you don't have the rules actually. What you do is you take both answers and questions and answers, basically data or the output is the final answer, and then you use them, data as the input and the answers, which could be labels, etc. And you use them to derive, the machine itself learns the rules models, which is what we are looking at. And this is a very different paradigm, and which is why it's important to mention it. That's what I thought. Because geospatial data is increasing like anything, and that's where role of AI is going to increase, because now we can't keep making rules for everything anyway. Other smaller things like why was the AI's purpose and value? And here, one simple way to obviously to describe would be that, let's say if I give you a small task of spot the differences between these two images, yeah, one can do it easily within a minute or two. But suddenly, let's say if I give you hundreds or thousands or maybe millions of images, then how would you do it? And that's where the promise of AI lies, that it can do it all automatically much faster once we have trained it to pick the right differences and all. So that's about the AI. Now, what I'll try to reach. Okay, so why we need geospatial, and that's where like my take, and based on some of the researchers I've read about, is we need to. So when we think of intelligence, it's not just about brain. And why? I'll just try to explain. So let's say when you touch a very hot object, before you realize you remove your hand, and that's not happening because your brain was able to send signal in time. It happened because you have some of the involuntary reflexes in your body also. So that's the point. Is brain is not the only thing. Brain is part of the. Brain is an organ which is definitely of critical importance, but intelligence is embodied in the whole body with our sensory organs and environment playing a big role, because we learn through interacting with the space or environment around us. And that's where the learning through interaction with the environment or space around us, that's what means to have a geospatial perspective. And that's, in some of the AI algorithms, that's definitely missing, and that's what GeoAI is all about. So moving on. Now, what makes geospatial different? Ali also mentioned the spatial autocorrelation, and yeah, basically, how do the fundamental principle in spatial science or geography is that most elements or cultural artifacts, they don't change suddenly in space and time, so they are related, and that's the nearby things are more related than the faraway things, and that kind of ensures the continuity is maintained. There are no sudden transitions in space and time, and that's what spatial autocorrelation is all about. Similarly, also the maps, the way we look at it, it's also they serve different purposes. So some of you might have seen this map. So this is like trying to show the actual area of the countries, and that's definitely very different. And this is just to make the point that maps are basically a projection, and the projections could serve different purposes. If you want to save direction, you need a different projection. If you want to save area, you need a different projection. If you want to save distances, you would need a different projection, etc. And that, which is what technologies like GIS also help us in, that they are able to transform between one to different to another projection easily. Another difference is about like, okay, this is a small exercise I've shown before also, but it's like if you ask Google Maps, what's the distance between Geneva and Switzerland? And that's a ridiculous question if you think in terms of, because Geneva is in Switzerland, but Google doesn't know that, or Google knows it. It's just like the way the current AI algorithms, etc., work. They don't seem to have that spatial sense, and that's why we definitely need to make sure that how do we impart that spatial sense into the AI algorithms, and that's what GeoAI is about. Similarly, there's another question like different distance between France and Germany. Again, it's a ridiculous question, but it takes the centroids of the two places and gives us a distance in between. So there are these things which show that yes, we need to think in terms of there is something different between the way AI people have been thinking about AI, and if you want to include the geospatial perspective. Another aspect is most of the in case of AI, most people either talk about computer vision or natural language processing. And let's say when we look at computer vision is focusing very narrowly in the visible spectrum of light only. But in the geospatial domain, people have been using the whole spectrum to a great extent. And I guess that's a big difference in itself. So algorithms need to be built and trained so that we can leverage the whole spectrum, not just the visible bandwidths. Another difference you can see is, let's say, if you look at a satellite imagery or any imagery from top, and you could see that there are elements, let's say, if there are farms or trees, etc., you move them around, not much difference would happen. This image would still remain the same. Whereas if you had an image of a human's face, you cannot move the nose to eyes place and eye to ears place, etc. So that's this is called region adjacency, and that's also very important because that allows us to even model it as graph networks in many cases, and that's a useful property to have. And point is like how if you want to leverage your leverage these properties to get our answers, then that's definitely helpful. But if you're ignoring, then we may be leaving something on the table. So overall, the summary is that yes, things that are closer in space and time are related, basically autocorrelation, which indirectly, because most of the machine learning algorithms go on the IID assumption that independent data is independent and identically distributed. Now, geospatial data doesn't follow that, so obviously that has to be taken into account. And we can see, like when you are dealing with spatiotemporal data, how these problems come across. You could try to sort, and then you'll find a lot of problem, because how do you sort based on nearness, proximity, or area size? You can't sort them based on latitude or longitude. Similarly, if determining if an object is inside the polygon boundary, like capital, the city is inside the country or not, so those are the kind of queries geospatial people would be looking at. Similarly, causality works in the direction of time, and that's when you're looking at some of the phenomena and trying to make inference accordingly. You can't, like other data, you can't go back and forth. So that's another important point. So what happens in spatial data science is we try to use specialized methods for geospatial problems. Like, we'll try to identify frequency patterns, spatiotemporal clusters, etc. And broad idea is to take advantage of these different properties like autocorrelation, etc., so that we can get answers better and faster. So which is what AI or GeoAI algorithms would be focusing on. Now, here's like and a lot of work on this has been done. So like OGC has been making standards around how do you work with geospatial data for long, and I'll quickly go through this one. Basically, because we have different kind of geometries and different kind of relationships, how do you manage that? And if you have, how do you use these different kind of geofeatures to feed into the machine so that you could understand those neighborhood-like relationships better? And that's where a lot of work has already happened and is already happening. Like these days, the OGCs focus a lot on geodata cubes. Now, like here's one other example. Even in terms of analytical needs, things could be different. Let's say when you're looking at clusters, let's say when you have, this is a specific problem where police patrolling routes are need to be recommended. Now you can't use clusters, as you know, and in this specific case, the paper focused on how do you identify the linear clusters where potentially illegal activity might be happening most often. And that's the answer. You can't use clusters in the traditional sense, the way most AI algorithms would provide you. But that's a big difference in itself. Now, here's a small table because other than autocorrelation, there's another property of spatial data, that's heterogeneity, and that also needs to be taken into account, because even though things are similar, they are not always exactly similar, and that's an important thing to know. And so while in traditional data science and AI related disciplines, you'll see, I'm just trying to give you some analogous methods which can be used to solve the problems. Like when you have linear regression, you could use, instead of that, spatial autoregression, and similarly, spatial decision trees. So people have worked on these ideas for some time. And CNNs, convolutional neural networks, are, because they look at the proximity, they are good for that purpose, and they work well on spatial data. But here we are looking at only autocorrelation, and still, like if you have to look at heterogeneity, then we have there have been geographically weighted regression and those kind of methods. So we need to use, and similarly, there's another method I came across some time back, and that's called SWAN, Spatial Variability Aware Neural Networks. And I'll just, it's an extension of geographically weighted regression only. I'll just quickly probably explain it. So here, basic idea is you just take the regression curve model only, but you have these beta and epsilon values which are location dependent. So basically, you use these when you're doing geospatial geographically weighted regression. That's what you're trying to use, and you use the same idea, and you are able to give specific weights to the different locations. Then, while feeding into the neural network, that's how you could create a new method. And this method worked quite well. So that's so that's a high level overview from me on like how we have been using geospatial AI. Also trying to contrast like how some of these things are different. Now I'll come to the next thing, which is like recently we have put it on, and if anybody has not taken this survey, I recommend you to please go ahead and submit this survey. It's a short survey, and Maria had suggested to conduct this survey. So Maria under UN-GGIM Network, and then we partner with Open OGC and WGIC also to spread the reach so that we can get more and more responses. Broad idea is to get sense from the private sector on what do they need in terms of GeoAI skills. So what do they mean, etc. Now, we have had some initial responses, and so initial findings are like some of the questions. Okay, so when it comes to addressing GeoAI talent requirements, a lot of people feel that it's very difficult to find, but that's so like 43% of the people feel that it's difficult to find good talent, and that's going to hurt them a lot. Whereas the other 57% of them think that it's hard, but they can always upskill their employees, and they're confident about that. And I think that's another thing which academics here needs to take into account, because I'm not from academics. I'll just try to share that a lot of people are looking at upskilling as a way out of this quandary and make sure that they have the relevant skills and capabilities. Another thing the questionnaire asks is, and which is where we got 50-50 of responses, like whether it's better to have a geography or geomatics related degree or a computer science related degree if you want to train people in GeoAI. And private sector answer is split evenly between the both. So I guess, maybe that's a non-answer in a way, but it seems like private sector is not distinguished between the two categories. Now, this is an important question, like, do university graduates have the required skills for GeoAI related projects they work on? And the answer was no. Like a large majority has already said that, that's not true. And currently graduates don't have those kind of degrees. So which is where the way Ali was approaching in terms of how to build the whole initiative, this talk and the later event which Maria would be talking about, they are focused on, we need to develop a curriculum for GeoAI which could actually serve the needs of industry and make sure that we are able to deliver that. Now, on some of the other findings, like, okay, there was unanimous agreement on the lack of GeoAI talent and capabilities at companies. Everybody said no, they don't have enough. But some of this, they like in the previous question I mentioned, some said they can train, others said they are not confident of even that. So that's seen. Other thing which people were had unanimous agreement on, and these results based. So I made this slide yesterday only. So and there are more responses which have come up, so things would change. But everybody said that they want to stay updated on scientific and tech advances in GeoAI research, and they had different kind of suggestions. Broad suggestion was to have a GeoAI hub for research updates. It's like 87% of the people said that they would like to have a resource like that. Whereas there were other kind of suggestions also there that maybe resources which could help people do some more of like just-in-time training, which I'm assuming is mostly going to be online. And how do you do social media-based knowledge management and create such repositories through social media itself? There was another suggestion on around having standards group for GeoAI, do something like that, and that's we already have one at OGC, so that's, I guess, but it's just like I'm just putting across the suggestions which came from the survey. We also asked like what kind of skills they expect or they want people to have, and which is where so I tried to synthesize what people have provided and some of based on my understanding of the field. Ali also talked about ethics and safety considerations, and he definitely asked more like deeper questions. I'm just leaving it at a higher level, but the broad idea is that yeah, we need to ensure that people are able to people first know and then are able to tackle any of the biases which are there in the geographical data because of, say, sometimes because let's say developing countries have a lot less data, whereas developed countries would have a lot more data. So that's data inequality. Sometimes scale itself is a problem because data, it could be different scales, different resolutions, etc. Even like the problems that get selected to be solved, and that there also the biases may come in from the people where they live in, and if people from developed worlds are going to be mostly selecting these problems, then that may not be accurate. It's just like those are some of the ethical considerations could be around that. The other considerations are around data privacy issues. Now, yeah, how do you manage that? And Ali rightly said that how do you identify the boundary when models have actually learned but not have the data with themselves? So, but there are issues around data privacies which can be managed through consent, or the ideas like self-determination or subsidiarity in data governance. Subsidiarity means that the governance of data should be handled at the lowest possible level where it makes best sense. So, that's the broad idea on like ethics side of things. Then when it comes to computational skills, yeah, they definitely need basic computational skills like basically programming languages, etc. At the same time, I try to divide the GeoAI solution, like how people will be finally solving GeoAI problems. You need 3 disciplines. Geospatial science, obviously, there are things which we need, the kind of exposure people would need. Similarly, in AI, Ali already mentioned some of these things, so I'll probably try to move along fast. The only thing I wanted to add was domain knowledge. Yeah, so this is where another, after you know something about geospatial science and also about AI, when it comes to domain knowledge, I think how do you make sure that your domain knowledge can get is used for solving the problems, which is like, okay, how do you do the data selection? How do you design the model? And also another way is like, how do you design your loss functions to ensure that models learn the right thing which you want? And we have used this in a specific application of carbon measurement in soil, where we use the physics of the systems, like law of mass conservation. We got much better results. So overall, I think this is the kind of skills people would require. Now, again, I'm an outsider. I'm not an academic, so I thought of putting this slide, but Ali already covered about it. But yeah, the only thing I wanted to say was the learning is not a spectator sport. You need much more of engagement, and that's all I wanted to say. My colleagues who are from academia and will be designing this curriculum. Another thing was, this is also Ali kind of addressed, but yeah, so we have some of, I've seen some of the like GPT, etc., have been able to do at least outperform special task specific models for toponym recognition or location mention recognition. They're doing very well. So instead of right now, they can't do very well on more complex queries like geoparsing or geographical question answering. But I guess it would be a mistake to assume that that won't happen. And assuming that happens, then how do we, indirectly what it ends up meaning is that almost everyone would be using GeoAI and or could be developing GeoAI algorithms using natural language interfaces. And that's where, how do we, how does the question is like, how do you design the curriculum in that paradigm? So I think, and Ali already kind of mentioned or hinted towards it, but when he said the pace of change in technology is very fast. So this is my last slide, I think. Thank you so much.
Thank you very much, Lukendra.
Yeah.
Thank you for bringing up the GeoAI survey, and the initial results are quite interesting. Thank you. So
Yeah.
we're going to move on to our last presentation will be given by Dr. Minxiang Zhou. Dr. Zhou is a professor of geography. He is the director of the Center for Human Dynamics at Mobile Age, and he's also the founding program director of Big Data Analytics program at San Diego State University. He received a bachelor degree from the National Taiwan University, a master degree from State University of New York at Buffalo, and a PhD degree from University of Colorado. His research interests are in human dynamics, social media, big data, public health, visualization, and WebGIS. His presentation is on integrating GeoAI with big data and metaverse for dynamic 3D and 4D GIS education. The floor is yours. Me.
Okay, thank you, Song Yang, for introductions. So good morning, everyone. So my name is Ming. I'm located in California, San Diego. So it's quite early here. It's about 7 o'clock in the morning. So the topic I'm going to focus on is a little bit focused on the application side of it, GeoAI using the big data and the metaverse, and it's specifically for the GIS application and educations. So before we go to the topic, I want to highlight the center I created about 9 years ago. It's called the Human Dynamics in the Mobile Age. The idea is to combine the multiple disciplinary and create a transdisciplinary research work, combining big data, human dynamics, and the social web, and using the academic innovation to try to solve the real-world problem, such as a disease outbreak, cancers, disparities, and also disaster evacuations. And in our center, we have a lot of the faculty from the many different disciplines, from the public health, from the geography, from the civil engineering, computer science, linguistics, social work, and the sociologists. And also about 4 years ago, I also created a new Master of Science program at San Diego State called the Big Data Analytics. And the focus into combining the GI science and the big data together and focus on the real world data analytics and trainings. And of course, the machine learning and AI is one of the major curriculum in these programs. So I'd like to first discuss what is the scope of GeoAI. I think the two previous speakers, Ali and then Cassandra, did a great job to introduce the GeoAI. But I think everybody probably are very familiar with this diagram. So from the Wikipedia or a lot of researchers mentioned that the relation between the AI and machine learning and deep learning is kind of like this one. The AI is like bigger pictures. Underneath, there's a machine learning focused on the computer algorithm and models. And deep learning is one a new development of the machine learnings and focus on the neural networks. So if we apply this three scope to the GeoAI, I would say that actually in the GIS science domain or GIS expert, we already conducting GeoAI maybe 20 or 30 years ago. So GeoAI is not a new thing. It's actually we are relabeling them together today because the popularity of the AI algorithms and then model today. So GeoAI, including a lot of our previous research work in the GI science, including the simulation, prediction model, and agent-based models. A lot of the people also focus on the natural language processing, specific for spatial terminologies and also spatial decision support system. Regarding to the geospatial machine learning, I think the previous speaker also mentioned a lot of like geographic weighted regression models, support vector machine, and also when we conducting the hotspot analysis using the GeoAI algorithm. Yeah, there's a lot of already existing algorithm is part of a geo machine learning. And also we can classify as a supervising geo machine learning or unsupervised geo machine learning. Finally, there's also with the new recent algorithm focused on the neural networks, a lot of geospatial deep learning algorithms are also available in many GIS applications. So I think, first of all, how can we integrate with the big data analytics? I think one of the domain I'd like to highlight is the social media. Like we have a lot of research analyzing the social media, such as Twitter or Weibo's, and they can using the geospatial information to identify a lot of issues such as air pollutions, disaster response, or even the pandemic predictions. Yeah, so those are a lot of potential. I think I want to give an example, like a lot of business banking company are already using the credit card history to set up a security system. If you're using your credit card at different country, at the same time, you'll trigger an alert for the credit card, like security. Yeah, this is one example, yeah, using the GeoAI to improving the security of a credit card system, and also using the geospatial location as one of the major variable to identify the issues or in the real world. So we can using the sensing with the location based, like such as your user's location to identify where is the major like robots to create the fake news or to create a redundant advertisements. So that's the things we can also utilizing those GeoAI technology to improving our social media analytics. Yeah, and also analyzing the different type of social media message during the disaster response. The second major area I'm thinking about is also to advance the human mobility model, is that predicting how we navigate through the urban areas or the cities, specifically like during the COVID-19 pandemics. We are a lot of research starting to using the GeoAI to predicting how the human or individual moving from one location or one city to another. And those agent-based model can also use for prediction of pandemics. And recently, also I was working on to create a virtual reality, we call the metaverse, for the GIS education. And one of the recent project, we are creating a very easy, low cost VR application using the Google Cloud. And we created it in this 3D virtual world. We are able to, idea is to teach the elementary students about how the safety issue when they travel from their home to school. So their route to the school, and specifically for those social vulnerable community in San Diego. Yeah, so when we're building this virtual reality in the metaverse, we also need to using the GeoAI to define every single element, like the vehicles, pedestrians, how they interact with each other, how they move around the cyberspace. And those things actually can utilize in the AI to define the rule and rather to predicting the existing rule. And we apply this application to the one of the elementary school in San Diego. And you can see some picture. The students are really enjoying those things. So I'm going to show you an example, a live feel of this virtual reality video games. Yeah, so if you can see my screen, so I'm going to run these games. Yeah, the game was created by the Unity as a very popular 3D model video game engines. So let's say that try to play the level one. So you can see that in this one.
Find the red flag to pass the level.
Yeah, so user can navigate and take a look about the traffic sign. Yeah, you can see when you move your cursor, you are moving around. Yeah, and then you can also see the map in here. Yeah. And when you press the button, you will see that the sign has been changed to the green colors. And when you can easy to navigate and then move around or move forward. You can see that the way we define in this metaverse, the pedestrian actually
Find the red flag to pass the level.
interact with the vehicle. Yeah,
If you are lost, remember you can use the mini map on the top right.
The home is honking. You can see that this is the rule, the AI defined by the pedestrian versus the vehicles. And the idea is they keep this safety information and to reach the other side of the cities with a landmark. Yeah, you can see that when they reach the landmark, yeah, they will accomplish this one.
Make sure to take off your VR headset before continuing.
So this is a good example of utilizing the AI in the metaverse. Yeah, and then the tool developing is actually very complicated. We're using the unities and also the blended GIS to building the 3D infrastructure. The actual building is based on the Google map and also the 3D structure around the elementary school. Yeah, so this is one of the challenging to create this AI in the virtual realities applications. So I think there's a lot of potential to combine AI with the metaverse. Yeah, you can, as I mentioned in the videos demos, we can define the avatar user and also other objects such as a car, raindrop. If we are doing some GIS simulation, how this weather, atmospheres, those simulation can be formalizing in the metaverse in the 3D and 4D applications. And also, if we can require a lot of GIS application that create the models, we can also using the AI help us to find the best combination of GIS method or algorithms, such as a model builder. So in the future, you can ask the AI, say, please find me the best site selection algorithm for my next building projects. So the AI can automatically combine different methods like overlays, reselections together to find the best solution for the models. I think the final thought for my talk today is, as the mentioned on the previous two speakers, we as a GIS scientists and GIS educators, we cannot work alone because we don't have a very comprehensive knowledge, and the AI technology is changing very fast. So we have to collaborate with other domain experts on the computer science, graphic design, data science, and together we can develop the better GeoAI education curriculum and also GIS, geospatial AI applications. And also, I like to highlight, as one of the previous speakers mentioned, the GIS application is actually very unique as a unique feature like spatial autocorrelations and heterogeneous. So we can actually using GIS as a glue to combine or linking all the different AI technology together, and also virtual reality, blockchain, and using the GIS application as a container to integrate all the state-of-the-art technology into these GIS applications. finally, for the some recommendation for the education, I think as an educator, we know that the GeoAI technology changing so fast. So we not only teaching the student the technology and skills, but we also need to highlight to train them to enable them, the student with a critical thinking, so they can identify the potential problem and also the risk of the AI if people can misuse or misinterpret the result of a GeoAI. So I think the balance between the training skill and the critical thinking is the very important issue in the GeoAI education. So that will pretty much end of my talk presentation today. Thank you for the listenings. So let me stop the sharings. Yes.
Thank you very much, Ming, for this interesting presentation. I think the timing is also very good. I guess the presentation with all these technologies also reflect what Ali mentioned about technical complexity, right, in terms of GeoAI. So I hope we will have more to discuss in the next 20 minutes. With that, I just want to thank all the presenters again for your excellent presentations. And then I'm going to hand over to Maria for moderating the next session. Thank you.
Okay, so thank you so much to the presenters and the moderator, Sun Yang, as well. So first of all, I want to say that I asked the organizer to share the link to a survey that the academic network, UN-GGIM Academic Network, is proposing to everyone. We want to have an overview about what is going, so what is doing, what the universities are doing with respect to GeoAI currently, in such a way to see if there is enough experience that we can consider useful for us. And then, as Sung Yang also recalled, what we want to do is to start thinking about a syllabus and a body of knowledge related to GeoAI. So first of all the presentations were absolutely interesting. I have some curiosity, as a matter of fact, and the first question is for Ali, because as you have experience, you already taught GeoAI. Ali, I want to understand what was the expectation of your students with respect to this new teaching in GeoAI, and if, in your opinion, in the end, they were happy about the course that you created for them?
Mm-hmm. Yeah, thank you, Maria. A very good question. Actually, like I said, one of the challenges is about the background of the students, and how you design a course should be fit to the background of the students. In my department, Department of Physical Geography and Ecosystem Science, a majority of the students that we receive are from have the background of a physical geography. So they have very limited programming knowledge and also data science knowledge, I can say. So for these students, this curricula that we designed was very interesting. They felt that it's a little bit heavy because they had to put more effort to actually learn programming first and then implement these machine learning algorithms, AI algorithms. But at the end, they were happy. They thought that they learned a lot. We have also few students that I expect to increase from engineering department, engineering faculty. And those students which have a very good programming background, they thought that the workload of the course is good. It's not much at all, and they learned a lot, and they were interested to learn more. So we run this course only one time this year. So the statistical population that I have is not good enough to say that if it's good or it's bad. But the general input that we get is that it's a good course and the students liked it.
Thank you. Thank you. It's very useful to know the experience of other professors because
Maria,
in my case I have
very quickly. Thank you.
Yes, sorry, yeah. So I was saying that it's really important to know the experience of other professors because, for instance, in my case, I had only very few hours related to GeoAI, but for sure we want to propose something next year also for our students. And so, Ming, do you have also experience in teaching to the students these topics? And in your opinion, which are the most important topics to be communicated, transmitted to the students? Now, Ali, you are muted. You are muted, Ali.
I'm sorry. It's difficult to categorize the topics. That is an issue itself. But if I say that we have optimization, that is how I categorize that. We have a machine learning and we have geosimulation. Actually, what I decided is that to include a little bit of optimization by focusing on only GA algorithm and NSGA2 algorithm, and more focus on machine learning, because machine learning is a trend these days. So I think that they need to learn about machine learning more than everything else. But optimization cannot be ignored because GIS, for example, all these site selection things are based on optimization. But I decided to skip geosimulation, at least for this course, because of the workload. I thought it's too much for the students. And at the end of the evaluation, we also thought that it's too much. But talking about algorithms, it's also very important which algorithm you want to pick. Then what we did, we just picked those algorithms which are used widely in GI community, we can say. And they were artificial neural networks, deep learning with a focus on CNN, all these random forest techniques, and some actually background courses to prepare prerequisites for them. So this is how we decided to select the topics. And then when you teach them techniques to the students, then no space will be left for non-technical aspects, for example, ethical aspects and actually legal aspects. Then we gave only one lecture to that part. That I think is not enough, but it gives insights.
Thank you. Thank you so much. Thank you. And I wanted to ask also Professor Zhu, so Ming, do you have experience with students, and in case what you recommend as the topics that we need absolutely to consider? Suppose that you have only 20 hours for teaching something about GeoAI. Which are the most important topics?
Yeah, actually, in our big data analytic program, we do implement a lot of courses like machine learning and big data analytics. Yeah, I think one of the key concepts we need to teach students today is not just algorithm or the techniques itself, but teach them how to self-learning the new things. Because today, a lot of people are actually using the YouTube, social media, or online learning tool to learn those new tool, new technology. So in my courses, actually, at the very beginning, the 2 or 3 lab exercise, I kind of listing the potential online resources and YouTube channels and ask them to search potential, the possible education materials. So I think we are not just teaching them the technology, but teaching them how to learn technology by themselves. The self-learning techniques is very, very important for the GeoAI education. Yeah, because you know that the new technology will emerge every 6 months. Yeah, students have to learn by themselves. Yeah, we cannot teach them all. Yeah.
Yeah, and I believe that another point that you touched in your presentation was really, really important. That is the critical thinking. we have to learn students how to evaluate the results that they get, because you know that with most of tools, we have always a map or some numbers representing something, but we must be sure that the students are able to criticize these results. And so I don't know if you are using some specific way for teaching these, if you are asking students to do some projects and then you comment the project with them. So which is the method that you are using for that?
Yeah, in my courses, I always have the midterm exam, focus on the theory and then like a fundamental concept. But every courses have the final project is a team group project. 2 or 3 students have a project, and we can as collaborative as a criticizing their presentation at the final end of semester. So I think this is very important. I always highlight the student that because there's so many algorithms, so many different models, your responsibility to choose the right model for the right problems. Yeah, so I think that's very important. So sometimes I will give them 2 or 3 examples of an algorithm and solve the real same problem, but there's maybe only 1 or 2 algorithms appropriate. The other one is maybe is not appropriate. They have to know that, because I saw a lot of problem for the student when they graduate. They're using the wrong tool to address the wrong questions. So I think that's a very important, teaching them how to selecting the appropriate GeoAI algorithm.
Yeah, thank you. Thank you. And as we were speaking about benchmarking and evaluating the different models and so on, I want to ask also Lukendra, because Lukendra is one of the chair of the Geospatial AI of the Open Geospatial Consortium. And so for sure, you are more than involved in the standardization and evaluation, benchmarking, and so on. So can you tell us what you are doing with respect to that in the Open Geospatial Consortium, and if there is also something related to education, or if there is a crossing point between us as educators and the Open Geospatial Consortium, Geospatial AI working group, and so things like that.
Hi, thank you, Maria. So that's an interesting question. So yeah, we are doing a lot of things at the GeoAI domain working group at OGC. One of the main things is like trying to understand what, at least, so while Ming also mentioned that, yeah, we have been doing GeoAI in some shape and form for 20 plus years, but as we know, the discipline has getting consolidated now. So one idea is, one thing we work on is trying to make sure that we get inputs from all the people who are actually working on GeoAI problems, or like using GeoAI to solve their problems, and try to learn from them like what exactly they are doing and what are the challenges they are facing. So the idea is, through those challenges, you can try to identify what needs to be done in terms of what kind of standards are required. So yeah, this question of having benchmarks, data sets, etc., has come up again and again, and that's so. Creating benchmark data sets is not an OGC mandate, but it has been noted that, yeah, there's something of big interest in the community. And another thing, like in terms of standards, we have got some suggestions and ideas from the community, especially around like how to label data, how do you manage metadata, how different GeoAI algorithms potentially be able to talk to each other. So you need standards for all of those things to make sure that everything becomes interoperable. So we have some ideas, and what our plan is to create a small short paper on broadly like a roadmap for GeoAI standards. So hopefully that would be ready in next few months, and then we'll release and ask everyone for inputs. So we'll have the first draft, then people will provide their input. So that's the other thing. Other thing which I realized is like, okay, I probably wanted to say, but I forgot in my presentation also, was there's a lot of interest in terms of cloud related functions. So when and I wanted to mention here, because when you're as academics, when you guys are thinking in terms of how do we design curriculum, is like now most of the work, I'm like, from the industry perspective, most of the work is now moving to the cloud. So being able to develop APIs, how do you use cloud related machineries, or how do you use containers, etc. That's part of the foundational aspects which people need to know. And that also, yeah. And then the other thing I probably would like to say here is, you guys kind of covered about in terms of multidisciplinary angle, but and you so like having a learn to teach kind of paradigm where students actually, the way Ming was saying, okay, they should learn how to learn. So that becomes part of their training itself. And see, in industry, you have people working on a problem, solving it together, and they get evaluated almost like together. Whereas in academia, everyone gets evaluated on their exams individually. And so basically, what you would consider cheating in academia is collaboration in industry. So I'm not sure, like, how do you manage that conflict, because you want to measure everyone's capabilities also. But I think that's something around that has to be thought in terms of, because that's how people could become ready for their jobs immediately. So that's another point I can add. Yeah, I guess that's it from my side.
Thank you, Rukendra. But I have to tell you that in some cases, students are working together in small groups. And so in some other cases, like for instance, in my courses, we have international students working all together, that it's also enriching more their experience, because they're also diverse from the origin, from the background as well. And so we are trying to do that. And so thank you. It's an excellent suggestion. We have to keep in mind this point as educator for sure. But sorry, I see that there is one question. Jorge Eduardo Aponte Gomez wanted to know how the GeoAI was used for the COVID-19 spread.
Okay, yes, thank you for this question. So actually, we can use in the GeoAI first to identify the hotspot and the cold spot of the COVID-19 pandemics. Like in San Diego, we actually find out the majority of a hotspot is located in the south part of San Diego, which is our Hispanic community resident area. And also we use in the GeoAI and the regression models to identify which social variable we call the social determinant of health has an impact to the COVID pandemics, like the confirmed cases. We found out that low-income families, low educations, and also minority group has much high risk of a COVID-19, even like a 3 times compared to the regular populations. And yeah, so that's one thing we use in the GeoAI to identify. And also, we also analyze the social media about how people respond to the wearing the mask or the intervention policy, so we can know that what kind of opinions, public opinion, to the public's decision making about the policy, public health intervention policy, and we provide that information to the County of San Diego officer, and then so it's very important to using the social media for the feedback of the public interventions. Yeah, and then finally, we also utilizing the GeoAI to predicting the model using the human mobility, and then we can simulate the spread of COVID between the cities based on how many people moving around different neighborhoods. So there's many applications. We use GeoAI for the COVID-19 pandemics.
Thank you. So I hope that the Jorge Eduardo Ponte Gomez was happy. The explanation was very clear. So thank you. And as we are almost in the end, I want to ask all our speakers if in just 1 minute they tell us if they believe that it's important to create a discussion around these topic that is creating a syllabus and creating a body of knowledge related to GeoAI, specifically for us as teachers, so as professors, educators, but also for the benefit of everyone, so the private sector, the public sector, and so on. How do you believe? Is it important? Do you think that it is something that we don't need, and so on? Very, very quickly, just 1 minute for every of you. Ali, you can start.
Yeah, I think the topic of GeoAI is indeed important. Who can say that it's not? We have actually large amount of geospatial data from satellite imageries, from all these crowdsourced data, from actually social media, etc. So it's important to be able to analyze actually these data with actually artificial intelligence techniques to produce more data. And in order to do that, and in order to support the industry to be able to do that, we need to train actually the next generation of experts in the field to be able to use GeoAI. So GeoAI education, I think, is needed, and more work is indeed needed in order to brainstorm how to develop a good GeoAI program or good GeoAI courses, because next generation is not still ready. We have many GIS students, but we don't have people or students who know what is GeoAI and how it can be used actually in practice.
So probably we need a collaborative effort, because the topic is very complex, it's rapidly evolving, and so we can obviously facing it individually, but probably if we work together in a collaborative way, that is much better.
Yeah, of course, I believe that a collaboration between informatics, let's say, AI experts and GI experts is needed in order to make it happen.
Thank you. And Ming?
Yeah, I fully agree with your opinion, suggestion. We definitely need to collaborate and maybe building a very nice online resource or the deposit, like a portal to combine. And maybe everybody can just simply to submit their curriculum or maybe some lab exercise. Yeah, so you don't need to create a very comprehensive learning module or the textbooks, but even everybody's, when they teach their AI, the GIS class with GeoAI, sharing their curriculum will be a wonderful resource, and everybody can help each other to see what's the differences between the course content or course lab exercise. Yeah, I think create a kind of a portal or hub to allow everybody to exchange the idea, and then syllabus will be great.
So thank you, and so probably you will appreciate what then Andrea will tell in the end, summarizing and telling which are the next events organized by AI for Good. But I want also to ask Lukenda, what about you?
Yeah, thank you, Maria. Hi, I do think that yes, that's a great idea. Only thing, and I guess you guys already covered how it should be done in a collaborative manner. The only thing I wanted to add was that because the content itself is evolving fast, rather than just thinking, okay, one is like static content, you create everything together, but then because it's evolving, it might be better to have a community thinking. So when Ming mentions GeoAI Hub kind of thing, so it becomes a community where you also can keep people posted on the latest research developments and how things. And this is something which came out from the survey anyway. Like people unanimously wanted to know like what's the latest happening, where it is happening, and how does it impact whatever the problems are. So I think that thinking it slightly broadly in terms of not just the core resource in terms of curriculum is also there, but then beyond that, how how the field itself is changing is another thing which people wants to know, and obviously would be of great value to anybody who studies GeoAI. That's it from my side.
Yeah, thank you. So at this point, I want to thanks again our presenters. In my opinion, was a very useful event, this one. And I have to say that we want not to be the last one, because we want to go ahead building together something related to education and GeoAI, because we really believe that now it's timely, and also that our students have expectation with respect to that. So it is correct to try to understand which are these expectations and give them what they need also for their career, their future, and also for building something that is sustainable for every one of us. So for their work, but for the world in general, for the Sustainable Development Goals as well. And so this is very relevant. So thank you, and I give back the word to Sung-Nyang before giving the final word to Andrea for summarizing.
I just want to echo what Maria said. Thank you very much. Especially I want to thank Ming for this. This is a really bad time for you to get up so early. Thank you all for your effort to make this webinar. So that's it. If you can all turn on your camera so we can take a screenshots. Thank you.
And Andrea, now the floor is yours. You have to close.
Yes. I thank you very much, Maria, Sung-Nyang, Lokendra, Ali, and Ming for this very, very much interesting session. And thanks the audience for your participation. I think that it was a very good event for introducing this GeoAI workshop that ITU will host on the 5th of July. That is just the day before the beginning of the AI for Good Global Summit. This GeoAI workshop organized under Maria leadership with the participation of all stakeholders like academia, private sector, the United Nations will debate how to build a foundation for Geospatial AI, defining a syllabus and body of knowledge. As also highlighted in the session, we just said that defining a syllabus would be very much important to clarify expectations and help with planning courses related to Geospatial AI, and also would help to highlight the importance of and relevance of this geospatial data in this emerging field. So we are posting the link of the GeoAI workshop in the neural network chat. Please register if you want to participate. At this point, I think that I thank you all for your participation, and I will give back the floor to our nice avatar, Anna. I thank you very much.
Thank you.
Bye.
Thank you.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop. and build your personalized AI for Good program. Let's shape the future of AI for Good.
AI is a powerful tool.
This summit can help ensure that artificial intelligence charts a course that benefits humanity and bolsters our shared values.